On April 13, 2025, a towering $500 million bridge opened, linking Sichuan to the Tibetan Plateau. Less than 7 months later, it was closed, as engineers raced to evacuate after discovering a 10-centimeter crack, just hours before 10,000 cubic meters of earth hurled a 758-meter span into the ravine below. 0 lives were lost, but the unanswered question remains: how did every warning about Hongqi Bridge's unstable foundations get buried until it was too late? April 13, 2025. After 5 years of relentless construction, the Hongqi Bridge opened to traffic, a 758-meter link stretching across the Zumuzu River Canyon. Its soaring concrete piers, each as tall as a 56-story tower, stood as proof of engineering ambition on the edge of the Tibetan Plateau. The project's price tag of $500 million made headlines, but the real stakes were political, as provincial leaders promised a direct route from Sichuan's industrial heartland to some of China's most remote regions. Ribbon-cutting ceremonies drew crowds and cameras, the bridge hailed as a flagship for the Belt and Road Initiative. Barely 6 weeks later, the landscape changed again. On May 1, 2025, the Shuangjiangkou Dam, just upstream, began filling its massive reservoir. This was no ordinary dam. At 312 meters, it was the tallest rockfill dam in the world, designed to generate 2,000 megawatts of power. The new lake crept higher each day, pressing millions of tons of water into the fractured limestone slopes that had always made this region unpredictable. The bridge and dam now stood side by side, 2 mega projects sharing the same unstable ground. As summer faded, the clock kept ticking. By early November, the dam's reservoir neared its highest planned level. On November 9, 2025, a grand ceremony marked the dam's official inauguration, with government officials, engineers, and media gathered to celebrate the achievement. The bridge, just 2 days shy of disaster, still carried the weight of daily traffic and the hopes of a region. No one paused to consider how quickly the milestones had stacked up. 5 years to build, 6 weeks from bridge opening to dam fill, and only 7 months of operation before the next crisis. The timeline was relentless, each event compressing the margin for error. In the shadow of the world's tallest dam, the Hongqi Bridge's fate was now tied to forces that did not care about schedules or celebrations. Every milestone checked off the list brought the next risk closer, even as the official ceremonies proclaimed success. On November 10, 2025, at precisely 3 p.m., a routine inspection on the Hongqi Bridge turned urgent. An official traced a jagged crack running 10 centimeters wide across the concrete deck, wider than a man's thumb. The ground nearby showed fresh fissures, and the mountainside itself looked unsettled. Traffic rumbled over the bridge as usual, but the supervisor on duty refused to ignore what the sensors were showing. Displacement readings had started climbing. Too fast, too soon. He radioed for an immediate halt to all vehicles and ordered the bridge closed, even as some questioned whether the crack was just a surface defect. Evacuation protocols snapped into place. By late afternoon, warning lights flashed at either end of the span. Drivers were turned away, and stranded vehicles were guided off the bridge in small convoys. The decision to clear the structure was not made lightly. Every hour the road stayed closed meant mounting pressure from above. But the supervisor stood firm. He walked the length of the deck with his crew, checking every expansion joint, feeling the vibration underfoot. Workers reported the bridge trembling beneath them, a low, unnatural sway that grew stronger as dusk fell. By 11 p.m., the last car had left. The bridge, now empty, stretched silent over the canyon. On-site workers gathered their equipment, some glancing nervously at the crack, others filming short clips on their phones. One foreman, voice shaking, recorded a message for his family, just in case. The supervisor checked the sensor logs one final time before locking the site gates. He knew what the numbers meant. The ground was shifting, and the bridge was no longer safe. No one slept well that night. Some workers stayed in nearby dormitories, replaying the day's warnings in their minds. Others left the valley altogether, unwilling to risk what might come next. The bridge remained deserted through the early hours of November 11, 2025. When morning came, only the wind moved across the empty span. The evacuation, prompted by a single undeniable crack, would be the reason not a single life was lost when disaster struck. Beneath the Hongqi Bridge, the ground was anything but solid. Construction records show each foundation pile driven just 20 meters into what was believed to be stable limestone bedrock. On paper, that depth met the minimum code. In reality, it barely scratched the surface of a landscape riddled with hidden threats. Karst limestone, shaped over millennia by water dissolving the rock, forms a tangled web of voids, some as small as a fist, others large enough to swallow a truck. Engineers relied on borehole cross-sections to map these cavities, but the surveys missed nearly 40% of the subsurface voids. What looked like continuous rock on diagrams was, in fact, a fractured maze. From the start, the bridge's support was fragile. Piles meant to anchor the structure rested on pockets of air and loose fill rather than solid stone. Every calculation, load, stress, shear, depended on the assumption that the ground would hold. But the margin for error was razor thin. In karst terrain, even a small misreading can mean the difference between stability and collapse. The bridge's foundation sockets, at only 20 meters deep, offered little resistance to shifting earth above and empty space below. Borehole logs from the pre-construction phase tell a story of missed warnings. Core samples showed occasional soft zones and water ingress, but these findings were written off as isolated. Later analysis revealed these were only hints of a much larger, interconnected void system. The true extent of the cavities remained hidden until it was too late. When the ground began to saturate, water found its way through cracks and fissures, seeping into every hollow. The limestone's natural weaknesses multiplied as pressure built from above and within. The bridge's designers had gambled on the ground behaving as mapped. Instead, the shallow sockets left the foundations exposed to every shift, every surge of groundwater, every tremor from the valley walls. As the days wore on and the reservoir rose nearby, the invisible network beneath the bridge became more active. Voids filled, emptied, and shifted. Each change eroded what little support the piles had. By November, the margin for safety was already gone, long before the first visible crack appeared on the deck. The Hongqi Bridge stood tall, but its roots never reached the stability its designers had promised. Pre-stressed concrete was chosen for the Hongqi Bridge's main frame, promising strength and flexibility over the yawning gorge. The design called for cantilevered arms to reach out from piers that soared 172 meters above the valley floor, taller than most city skyscrapers. Each span depended on a precise balance, the bridge's own weight, the pounding of trucks, and the shifting forces of wind and rain all had to flow through the structure's core and down into the foundations. When the bridge opened, engineers calculated a comfortable reserve, what they called the factor of safety, meant to absorb unexpected shocks. But as months passed, that margin quietly eroded. Finite element analysis, run after the disaster, paints a stark picture. At the moment of failure, the bridge's load path did not just approach its design threshold, it was pushed to 1.8 times the intended demand. Forces meant to be distributed across the entire frame instead concentrated at the weakest points, the cantilever joints, and the interface between pier and deck. The pre-stressed tendons, designed to hold under immense tension, began to yield. Concrete, which can withstand crushing pressure but not pulling, started to crack at the microscopic level. Each vibration from passing trucks, each subtle shift in the ground below, amplified those tiny fractures. Over time, these microcracks multiplied, linking up to form hairline fissures that snaked through the deck and beams. The bridge's reserve capacity, the difference between what it could handle and what it actually faced, was consumed bit by bit. As the western approach lost support from below, the remaining structure was forced to absorb loads far beyond its intended limits. Strain maps from the post-collapse analysis show stress fields radiating out from the failing foundation, with red zones clustering around the tallest piers. The columns, once symbols of engineering prowess, became the fulcrum for disaster. At critical joints, sensors would have detected sharp spikes in strain and displacement in the hours before collapse. But by then, the material itself was already giving way. The bridge's failure was not a sudden snap, but a crescendo of stress, fatigue, and overload. Microcracks seeded during rushed construction and months of vibration became the hidden fault lines. When the final surge of force arrived, nearly double what the design allowed, there was nothing left to absorb it. The structural frame, once celebrated for its elegance and strength, reached the end of its capacity. The collapse that followed was the inevitable result of a load path forced past every limit, with no margin left to give. At 4:10 p.m. on November 11th, 2025, the surveillance cameras fixed on the western approach of the Hongqi Bridge captured the moment every engineer dreads. The sequence began with a deep, silent shudder. Barely visible, but enough to send a ripple through the span. In the space of seconds, the slope beneath the approach gave way. 10,000 cubic meters of saturated earth, loosened by weeks of rising groundwater and hidden voids, surged downslope in a single massive wave. The ground that had held the bridge for 7 months simply vanished. Support columns, once anchored in limestone, lost their footing almost instantly. 80% of the foundation's bearing capacity disappeared in a heartbeat. The cantilevered arms, built to balance the weight of concrete and traffic, found themselves suspended over empty space. Electrical lines stretched to their limit, sparked and snapped as the deck twisted. Surveillance footage froze the moment sparks erupted at the bridge top, white flashes against gray sky, while the main span fractured at its joints. Pre-stressed tendons, pulled far beyond their design, recoiled and tore through the concrete shell. The collapse was not a single fall, but a chain reaction. As the western approach dropped, the deck split along the expansion joints. Segments tilted, then tumbled into the ravine below. A plume of dust erupted, billowing upward and outward, marking the site for miles across the valley. The force of the impact sent shock waves through the canyon, stirring up debris and silencing the usual echo of traffic. Forensic review of the video reveals the sequence. First the landslide, then the loss of support, then the structural failure cascading from west to east. Every element, earth, concrete, steel, reached its limit in less than a minute. The bridge's final moments, preserved frame by frame, left no doubt about the mechanics of failure. Where there had been a continuous span, only fragments remained, scattered across the canyon floor. The dust lingered long after the movement stopped. In the aftermath, investigators would replay these 60 seconds again and again, searching for answers in the details. The initial surge of earth, the precise instant of support loss, the telltale sparks, the shape of the falling deck. The evidence was clear even before the dust settled. What held the bridge up had disappeared from beneath it, and nothing in the design could save it once the ground gave way. The paper trail behind the Hongqi Bridge collapse runs deep, and it does not flatter those in charge. In 2023, An independent geohazard audit flagged the very dangers that would later destroy the bridge. The original draft circulated among technical staff warned of shallow foundations in karst terrain, insufficient drainage for heavy rainfall, and the unpredictable nature of the limestone beneath. When the audit reached the approval committee, the language had been softened. Warnings about urgent risk of sudden foundation failure were replaced with instructions to monitor for settlement. Recommendations for deeper piles and expanded grouting were trimmed to consider further geotechnical review if schedule permitted. Meeting minutes from the final design phase reveal the crossroads. One line stands out. Deeper borings were discussed, but set aside to keep pace with construction targets. The record shows engineers understood the risks, but the pressure to deliver on time outweighed caution. Schedules, not soil, set the limits. The focus shifted from what lay hidden beneath the bridge to the visible progress above it. After the collapse, the auditor who first raised the alarm reviewed the evidence. The structure performed as designed, but the foundation was never truly there. Forensic mapping confirmed the worst fears. Voids and cavities ran through the limestone, undetected and unaddressed. Every softened phrase in official summaries, every waived inspection, stripped away a layer of defense. The collapse was not a surprise to those who had read the early drafts. The warnings were there, spelled out in black and white, buried under layers of softened language and political urgency. The evidence leaves little doubt. The disaster was foreseen, and the decision to ignore it was documented long before the ground gave way. Today, over half of new megabridges worldwide face the same collision of rushed deadlines and ignored warnings that doomed Hongqi. Political targets still override geological facts, and sensors flash red in silence. The next collapse is already seeded wherever scrutiny gives way to speed. Every decision not challenged is a risk multiplied. Which bridge and whose lives will pay the price next? Share your perspective below.